Hello, welcome to ANS Solver. This is the third question of the paper, and as you can see, this is a parametric equation question. Okay, so now we need to show that dy by dx is equal to cosec 2t. So you need to know that dy by dx, okay, can be written as dy by dt over dx by dt. Okay, so what do I need to do first is I need to calculate dy by dt, which is basically the differentiation of this. So now let's go step by step. Think of brackets like this. What is the differentiation of ln first? It's 1 over x. So I'll write this as 1 over 1 minus cos 2t. But this will be multiplied by the inner bracket, which is 1 minus cos 2t, but the differentiation of this. So the differentiation for 1 is 0, and the differentiation for cos, I know, is simply minus sign. So this becomes sine 2t because the minus and minus gets cancelled. But now if you see, there's another inner bracket here of 2t. So we multiply the differentiation of 2t also, which is 2. So I can write this basically as 2 sine 2t over 1 minus cos 2t. Now I can calculate dx by dt. So what I can simply do is I can differentiate this. So now the differentiation for 2t is simply 2. Okay. And now the differentiation for sine is simple. The differentiation of sine is cos. So I'll write cos 2t, but I told you chain rule. So the differentiation for 2t will also be multiplied. So I'll get 2 plus 2 cos 2t. So now I can get my dy by dx. Okay. I know dy by dx is dy by dt over dx by dt. So it's simply 2 sine 2t over 1 minus cos 2t divided by 2 plus 2 cos 2t. So I can write this as 2 sine 2t over 1 minus cos 2t multiplied by 2 plus 2 cos 2t. Now what I can do is I can simply write this as 2 sine 2t over, I can take 2 common here and write this as 1 minus cos 2t multiplied by 2 multiplied by 1 plus cos 2t. I can simply cancel the 2 and 2 here to simply get sine 2t over, if you see, the denominator is now written in the form of a plus b into a minus b, which can be written as a square minus b square. So now I can simply write this as 1 square minus cos 2t the whole square, which can basically be written as sine 2t over 1 minus cos square 2t. Now what do I need to prove? I need to get cosec 2t. That basically means I need to get 1 over sine 2t. Okay. So now I have something like this. So if you know here sine square x plus cos square x is equal to 1. That means sine square 2t plus cos square 2t will also be equal to 1. Okay. So now I can simply say sine square 2t, sine square 2t can be written as 1 minus cos square 2t. Okay. So I can simply write this as sine 2t over sine 2t the whole square. Understood? This is a really important step. You need to know a little bit of trig identities. So basically you need to know this. So now I can simply cut this and I can cut this to get 1 over sine 2t, which gives me cosec 2t, which is basically the final answer of my question.